I'm your host, Sean MacKenzie. Thanks for joining me once again on my channel on data engineering. In this episode, we go back to our Python on Snowflake playlist, and I want to talk about how to do SQL joins and get your Pandas Dataframes as a result. Now, this is a very, very handy way of approaching getting data from Snowflake, and most Python programmers are tempted to use merges and things like that, when actually you could be doing the joins on the back end and leveraging all that power that's back there to speed things up. So without further ado, let's get to our SQL joins on Pandas on Snowflake. Need to hire additional programmers for your project? Make sure to check out the links in the description. Okay, so I'm using the idle shell here, and I'll start a new file, and then I've created some variables. When I save it here, I've created some variables which I've scrolled off the top of the screen so that you can't see them. But they're called snow user and snow pass, which we'll use later in our procedure here. And what I'll do is I'll import snowflake.connector, and I'm going to import pandas as well. And I'll give some feedback here, just saying, into the console, just saying, opening Snowflake connection, and then we'll create our connection for Snowflake. So we'll use CNN equals snowflake.connector.connect, and then we're going to throw in our username and password, and as well for this connection, I'm going to put in also the database name and the schema name, which is kind of a nice way of doing it when you're connecting, so that you immediately go directly into the database and schema that you need. Now, you can make a connection without specifying the the database and the schema, but at that point, then you need to send the SQL command for using. So we'll use the use command. So you'd say use database, use schema, and those will get you to where you want to go. But you can include the warehouse, the database, and the schema right in your connection, which is really nice because it sends you right where you want to go to do the work that you want to do. And so in this case, I've got a warehouse that I created called Project Warehouse. I've got a database called Project Database, and a schema called Project Schema. And this is a project-related database and schema. And so what I did was I created some tables that have a few records in them that can be joined. Now you could think of these as having a ton of records in them, something that you might, it might take a long time to merge, and that's sort of how we're going to move forward with this. So I'm going to create a cursor, the CS equals CNN.cursor, and then I'll do SQL is equal to select star from projects, just to show you what's in our database here. And what I'm going to do first is I'll do a cs.execute on my SQL there, and then I'll say my data frame, my pandas data frame is equal to cs.fetch pandas all, which is a very handy command that comes with comes with the Snowflake connector, and that's going to create that data frame in pandas that we can use, and it's going to have all the characteristics of a data frame, pandas data frame, that we've sort of gotten from Snowflake. And so if I go ahead, I can give some feedback to the user, just saying we're going to close that connection, because it's good to close the connection before you start doing things that might throw an error or whatever. You should actually put this in a try except block, but just generally speaking, it's good to close your connections before you move on, once you've got your data out of your data source. And so I'll print data results, and then we'll print off the data frame head 10. I don't even think there's 10 records in there, but I'll just say .head there, and then we'll hit F5, and that's going to execute our SQL. And as you can see, it grabbed an ID, a project name, and some details about the project. I'll do the same thing for our staff so that we can see the staff entries. So I'll say SQL is equal to select star from staff, and then we'll grab that one in much a similar way that we grabbed the earlier one, just to show you what the data looks like. I'll call it DFS here in order to designate that it's for staff. But first we'll execute that SQL so that we can get it out using fetch pandas all, cs.fetch pandas and we'll do that now. So now we've got a staff table, and we'll take a look at that one as well. And I'm also going to grab the table. Now I'm just going to copy and paste it this time. I'm going to copy the junction table, which is called project_staff. So that has that table creates the many-to-many relationship that we're sort of looking at here. So I'll call that one DFPS, and so what I'll do is I'll print both of those tables, and so that you can sort of get an idea of what the data looks like and how you might go ahead and either just directly export or import this into Pandas, or whether you might use a Pandas join, or whether you might do SQL join on the back end. But this is what the data looks like, and so you can see there's the ID and the project name, project description, and then there's a staff, with the staff ID, first name, last name, and there's there's a project staff table where it's got the project ID and the staff ID, and that creates a many-to-many relationship between the tables. And so you could, if you needed to put these into one table, you could merge this using Pandas Dataframes, using a join or something like that. But generally speaking, I like using SQL for these in relational databases, and actually you can use SQL quite well in Snowflake as well. It's very, very handy to be able to use the SQL for those statements and get back the result sets that you need, and that allows you to sort of use the power of the backend that's on Snowflake and to do these massive joins. Now in this case it's just a few records, but if these had a lot of rows in them, you'd probably start to see performance decline if you brought them all over and were using them in Pandas joins, as opposed to just doing a select statement with your joins in SQL against the Snowflake database. So in my first SQL statement here, where I'm going to do a join, I'm going to take the last name, first name, and the project name and the date they started on that project, and I'm going to grab that from the project staff table. So that's the junction table. So I'm going to use that to start with, and then I'm going to do an inner join with the project table and an inner join with the staff table. So I'll use the short form. I'll just say join project join project PRJ on PRJ.id is equal to PSF.project ID, and then I can that's going to give me a join there, and then I'll also join staff as STF on STF.id is equal to PSF.staff ID, and this is sort of what you might see in typical real-world situations with having to join these together like this. And as you can see, I missed a quote there, double quote. So now if I close that off, looks like it checks out okay for that statement, and we can go ahead and we can grab that result from our query without having to join anything. We can just grab it right out of Snowflake using joins, and that's going to go a lot quicker than if we did this locally. So I'll create this additional data frame here. I'll call it data frame all assigned, and we'll use our trusty cs.fetch pandas all to give us a data frame back. And then I'll just get rid of these print statements here because you've seen what the data looks like already. And I'll go ahead and I'll just print that data frame off so that we can see, the results of that using the SQL against the Snowflake backend. So there we go. I'll print the df all assigned, and I'll grab the head of that as well, even though in this case there's only a few rows. But if you have 10 million records, you probably only want to grab the head to see some result. But there we go. So this is all the assignments. So you can see Wanda Cooper's on the blueberry farm, and you can see McDuff there, Archie McDuff. He's working on the skyscraper. He started on April 14th, and James Duncan, he's on the marathon. But you can see there's 2 people on the marathon project, and so we've got some assignments there. And one of the nice things that we can do, using the SQL is we can do similar kinds of SQL operations. So we could do a mismatch query where we show, show me all of the projects that don't have any staff, or all of the staff that aren't on any project. Those kind of queries, we can run those in just the same way, which is really great, and so that can save a lot of time. So like if I did this, a similar query, and I said, select the project name from project, and if I did a left join, and I did project staff at on our ID field, just like we did before, but now it's a left join, but we'll say where the ID in the project staff table is null, and that's going to give us all of the projects that don't have any people on them yet. So you might have a similar situation to this in your Snowflake database, where you need to tell who's not assigned, or which ones don't have assignments, or those kind of situations. So we'll do the same thing. We'll do our cs.execute SQL, and then I'll say df project no staff, give it a nice big long name there, and then we'll use our cs.fetch pandas all, and then we'll go from there. And now I'll print that one off instead of the df all assigned. So I'll just copy that name there, and I'll go down, and I'd like to show that in our output here and our data results, which I can do, and I'll just paste that over that one and save it, and then hit F5, and I broke it already. There we go. Oh, missing a double quote. So there we go. So now our statement looks better, so I'll hit F5, and let's see what we get here. So we're opening our Snowflake connection, and there you go. So the data warehouse project, which is the last project in our list up top there, it has no staff on it. So so our query was able to tell us that, and we could do the reverse of that by finding all the staff that aren't assigned on any projects yet, which we can do in a similar fashion. So in that case, I could do select last name, first name from staff, and then do the sort of the opposite of what we did before, where I can say join project staff, which is our junction table, on on the ID fields, just like we did before, and then we'll also use the we'll use where clause, where our ID in the project staff table is null, and so we can do that here. So I'll go ahead and where the PSF .id is null, and that's going to give us all of the staff that are that don't have any assignments yet. We'll do our cs.execute SQL, and then I'll call this one df staff not assigned, and then that'll give us a data frame that we can use to get that, and use our fetch pandas all again, and I'll copy that one down there and just take a look and see here. We'll scroll down and put that in our print statement just so that we can get that one statement out just for demonstration here, and then we'll hit F5 and see what we get from that. So let's go ahead and hit that one, and oh, that one gave no results. I must have did something wrong. Looks like left join. Yeah, I didn't put left in front of my join there. So you need to put left join. It's very important if you're trying to do a mismatch query. So now if I hit F5, there we go. Okay, so we've got Mary Smith, and she is not on any project, so we can assign her somewhere else. And that's how you can do SQL joins on Snowflake. Need help or coaching on your project? Make sure to check out my Patreon. The link is in the description. Hope you enjoyed today's discussion on how to get data into your Pandas Dataframes by using SQL Joins on Snowflake. If you like what you saw today, please give the video a thumbs up. Make sure to subscribe to the channel if you have not subscribed yet. Click the bell when you see the bell, and if you have any questions or comments, please put those in the comment section below. Have a great day, have a safe day, and I'll catch you next time.